Hello guys, welcome to my first YouTube channel. In this course, as you see in my screen, I'm going to teach the multivariable and differential equation course. Um, I'm going to teach in Arabic and English, so most of the people I hope can understand what I will say. مرحبا فيكم جميعا. مثل ما قلت أنا رح أحاول إني أشرح مادة المالتيفاريبل والديفرنشال equation وراح أحاول اشرح كل شي بقدر عليه مشان خلي الجميع مستفيد إن شاء الله. So, as you all know, this course is really big and I will try to cover it a lot. I hope so, hopefully. In the first unit, you will see, as I wrote here in the screen, the partial derivatives. So let me go to this painter here. The partial derivative, you can say it will be written like this: z is equal to the f of x and y. Okay, so this is the partial derivative. I will try to give you a lot of example, and I'm not going to talk a lot, but I will give you whole bunch of example so you can understand every single piece. راح اشرح لكم وجاب لكم أمثلة بكمية كبيرة بحيث إنه الكل يكون مستفيد. Okay. Let me just describe a little bit of the partial derivative. The normal derivative is, you say like y is equal to 4x. This is the normal derivative. If you want to take the derivative for this one, you say y prime is equal to 4. This is the normal derivative, we take it with respect to x. You took this in maybe high school or maybe in calculus 1 and 2, but in the partial derivative, it's really different. So let me describe you a little bit what partial derivative mean. The partial derivative, you have to take with respect to x and y. Let me give you a simple example. Let's say f of x and y is equal to 4x times y. To solve this one, you need to solve it by taking every single piece in partial derivative. So firstly, I will take the partial derivative with respect to x. So the derivative of x here is 1. So the answer will be 4y. Also, the partial derivative with f of y, you need to take the derivative here for y and leave the x alone because you need to treat it as a constant number or variable. So it will be 4x. This is it. Okay, that's fine. Okay, where is the brush? Okay, so let's take this example right now. It says here, find the partial derivative of 2x cubed y square minus x cubed plus y square plus 4. To take this partial derivative, as I said, we need to take the partial derivative with respect to x and with respect to y. So let's write here the answer. So f of is equal to, let's take this derivative right here. It will be 2 times 3, it's 6x, 3 minus 1, 2. The y, you need to treat it as a constant number, variable, so you need to leave it alone. You don't change anything about it. So y square minus, here, x cubed, it will be 3x square. Here, there is a y variable alone, so when you see a y alone, it's a constant, and always the derivative of a constant is 0. So it will be plus 0, we don't have to write it, plus 4. 4 is also a 0, constant number, so you don't write anything. So this is the derivative with respect to x. Let's take right now the derivative of y. So f of y is equal to, here x cubed, it must be constant, so we need to play with this y square. So it will be y square, the derivative is 2y, so 2 times 2 is 4. So 4x cubed y times y minus x cubed is 0. Why? Because x is constant 0 with respect to y right now. We're not dealing with x, we're dealing with y. So when you see a variable alone, it must be 0. It's the same as the number. So here is 0 and here is 0. So what's left here? We have y squared plus 2y. That's it. Okay, let's take another example. The second example says f of x and y is equal to x times sine of x times y. So we need to use the partial derivative of x and y. So first, if you take the partial derivative with respect to x first, okay, here there is an x, and inside the sign there is also an x. So when you take the derivative and there is two variables the same, you need to use the product rule. If here there was no x, you cannot use the product rule, so you can solve it easily. But here, as I said, there is two products, two x's in the same variable, so you need to use the product rule. The product rule said v times u prime plus u times v prime. So the x here, let's start with the x, or you can use the opposite, it's not different. X here, for example, is the derivative of x is 1, so what's left is sine x y, and then plus the product rule here, sine x of y, the derivative of x here is 1, so x times y sine x y. That's it. For f of y with respect to y, the second one, what is the example? Yeah, here. For taking with respect to y, we deal with x as a constant, and y we take the derivative. So the derivative of y is 1. So f of y is x sine x y, and the derivative of y, as I said, is 1. What's left here is x times x. So here you can say x times x is equal to x squared sine x y. And that's the answer. With exponential functions, let's take this simple example over here. For example, f of x and y is equal to the x to the y when x is bigger than 0. To solve this, you need to take the partial derivative with x first, and here with y. To solve this with respect to x first, you need to solve it by taking the normal derivative with the x. So take the normal derivative for the x. Like for example, if you have x to the 4th, how can you solve it? You say 4 times 4 to the minus 1, which is 4x cubed. You can use the same way in this example. So you can say y times x to the y minus 1. That's how you can solve with respect to x. If you want to solve with respect to y, you need to add ln. So you can solve it by adding the ln times this function. So you can say x to the y times ln x. Let's take another example. Okay. The second example is f of x and y is equal to ln x squared plus e to the 2y and times x. To take this partial derivative, let's take the partial derivative with respect to x first. The derivative of ln x is 1 over x. So to take the partial derivative in both x and y, you need to take the partial derivative the inside over the normal equation. So here, with respect to x, you can say x squared with respect to x, it will be 2x plus here e to the 2y times x. So the derivative of x here is 1. So what's left here is e to the 2y. E to the 2y over the normal equation. X squared plus e to the 2y times x. This is the partial derivative with respect to x. Let's take the partial derivative with respect to y right now. The partial derivative with respect to y is, here let's write the normal equation below, 2y times x. X squared here is 0 because we're dealing with respect to y, not with x. So we can write here 0, or you don't have to write it, that's fine. 0 plus here e to the 2y. So let's say for example the derivative of x is e to the x. the same. But if you have, for example, e to the 2x, it's not the same. So e to the 2x derivative, it will be 2 e to the 2x. So we can write here 2 e to the 2y times x. And you can write, to make it shortly or formally, you can say 2x times e to the 2y. And that's the final answer. What if you have 3 variables instead of 2 variables as we solved before? Like for example, if you have x, y, and z, how can you solve this one? So let me give you a simple example to describe everything. Let's say for example here, find f of x and f of y and f of z. Okay, the equation is f of x, y, and z is equal to x times y square z cube plus x cube times y plus ln with brackets x times z and plus x square. Don't be afraid, it's not that big deal. You just have to take the derivative or the partial derivative with every single variable with respect to x, with respect to y, and with respect to z. It's really not that difficult. Let's say here we want to take it with respect to x first. So here, with respect to x here, so the derivative of x here is 1, so what's left here is y square, it's not cube, square z cube. Here we finished. Let's take this second partial plus the derivative of x cube is 3x square times y plus the ln x times z. The ln, as I said, it's 1 over x, or you can say it's the derivative of the inside over the normal equation. So you can say, we can write here the derivative of x here is 1 times z is z, so z over x times z plus the derivative of x squared is 2x. You can take here z, you can take z all, because z over z, you can take it to make it more simpler. And the second, the partial derivative, the second partial derivative is y. The partial derivative of y, let's see here the second. Let's use this razor here. Okay. We need to deal with y. So y squared is 2y. So 2 times x times y times z cube plus the derivative of y is 1, so x cube is left, plus inside the ln there is no y, so it's 0, and plus x squared is also 0, so this is the final answer. This is the final answer here. Let's find the third one, or the last one, you can say, f of z. Let's make some space here. make some space. So f of z is equal z cube. So it will, the partial derivative of z cube is 3z squared. So 3 times x times y squared times z squared, because here cube 3 minus 1 is 2, plus here there is no z, there is only x and y, so it's 0, plus the ln inside here there is z, yeah, so we can use the partial derivative. So it will be, the partial derivative of z is 1, so x over x times z plus 0, because x squared is alone, or it's a constant number of variable, we can say. So here we can take x and x, so the final answer we can write it 3x y cube z square plus 1 over z, and that's the final answer. Let's say, for example, if you want to find the partial derivative in an equation with a given point. For example, here, as it's shown, find f of x and y at the point 0 and 5. Let's make a simple equation from our mind. For example, f of x and y is equal to 5x squared times y. So first we need to take both partial derivative f of x and f of y. So the partial derivative here with respect to x is 10 x times y, and f of y, the partial derivative with respect to y here is 1, so what's left here is 5x squared. After we made the partial derivative, we need to fill the point right now. So here 0 is x and y is 5. So to find in every point, just fill 0 with x here and 5 with y, and you can find the point at every partial derivative with respect to. So here 10 times 0 times 5 is equal to 0, because everything with multiplies with 0 is 0. Here the second partial derivative with y here, 5x squared, is also 0. Yeah, but normally you have to, the number must not actually be 0, yeah, but this is how can you do it. Just fill the point, and this is the final answer. I hope you find it really helpful, and I will give you more examples, hopefully. Okay, let's say, for example, if you want to find the slope, for example, at a point. Let's say here, find slope. Slope at, okay, let's change here to 0. I'm done with this. Let's say at the point, for example, 2 and 1. Let's make also another equation from my mind. Let's say f of x and y is equal to x cubed and y times y squared. Okay, so just find the partial derivative first with respect to x and with respect to y, as we done before. Here, with respect to x is 3 equal to 3x square times y squared. And here with respect to y is x, sorry here, 2x cubed times y. Here we wrote 2 because I took the partial derivative with respect to y. Here it's 2 times y over 2 minus 1. If you don't know how we make it like that. Okay. Then let's continue. After we made the partial derivative with every variable, we put the point right now. So 2 with x and 1 is for the y. So here f of x is equal to 3 times x squared, so 2 times 2 is 4, and times 1 squared is 1, is equal here 1 times 4, 4 times 3 is 12 for f of x. Let's take the second one. F of y is equal to 2 times x cubed, so 2 times 2 times 2 is 8, 8 times 1 is equal, 1 times 8 is 8, times 2 is 16, and that's the final answer. Okay, let's solve the last equation for this video, which is about the square root. If you have a, for example, normal equation filled with square root and you don't know how to solve it, so I will give you the easiest square root equation so you can deal with it. Let's say, for example, f of x and y is equal to the square root of x squared plus y squared. Okay, let's take the partial derivative, but before making the partial derivative we need to change the style of this square root, so we can write it as a power. So we can write this equation as x squared plus y squared to the 1 over 2. This one is the same as this one, right? Nothing changed, but I just changed the way so I can solve it more easily. So every time you see a square root, always change it to the power. Don't leave it like that. You will be stuck, believe me. So let's take from here, for example, the partial derivative with respect to x first. Okay, so to take the partial derivative here, you can we need to multiply here with 1 over 2, so 1 over 2 times x squared plus y squared to the 1 over 2, which is this one, and we need to say minus 1. It's the same as if you say n to the, for example, 2. We write 2 times n, let's say here, yeah, it's 2, to the 2 minus 1. This one is the same. Don't take it too complicated. Okay, let's continue. So, and then times, this is a chain rule, so 2 times, sorry, x squared, the derivative of the x squared is 2x for the partial derivative. For the y is 0 plus 0 and equals, let's say, 1 over 2 x squared plus y squared. 1 over 2 minus 1 is negative 1 over 2 times 2x. Okay, we can also solve it. This one is minus 1 over 2. We can flip it to the denominator, so it will be 1 over x squared plus y squared to the 1 over 2 to the 1 over 2, and here we have 2, and here we have 2x. We can take the 2 from the top on the bottom, you can take it, and what's left here, the final answer for this equation is x over x squared plus y squared to the 1 over 2. 1 over 2, yeah. And this is the final answer with respect to x. This is with respect to x. Let's solve with respect to y right now. With respect to y. Okay. With respect to y. Okay. Here, everything here is the same. 1 over 2, we take it here, and we say 1 the power 1 over 2 minus 1, and the difference is the partial derivative of the inside. So the inside here is x squared dealing with y is 0 plus y squared is 2y. 2y equals 1 over 2 x squared times plus y squared minus 1 over 2 times 2y equals, let's take those to the bottom of the equation, so we can write x squared plus y squared to the 1 over 2 1 over 2, and here we also have 2, and at the top we have 2y, so we can cancel 2 with 2, and what's left for the final answer for this equation is y over x squared plus y squared to the 1 over 2. I hope you find it really easy. If you have any questions, you can ask me, and I hope I can help you. And one last thing, if you don't know why we made a chain rule here, it's we really use chain rule everywhere. For example, let me give you let's say, for example, square root of the x. Okay, we can write it as x over 1 over 2. So if you take the derivative for the x here, we say 1 over 2 times x to the 1 over 2 minus 1. Also, the derivative of x here is 1, but we don't write it because the derivative of x is 1, so we don't use it. Okay, so here is the same concept. So we took here the chain rule because we're dealing with x and y, and the variable also is not x, for example, or something. So yeah, it's different. If you have any questions, again, please tell me, and I hope I can help you with everything. Thank you for watching, and subscribe and like, please. Yeah, thank you. شكرا لكم جميعا. بتمنى انه فدتكم ببعض من الامثله، وراح احاول اني ان شاء الله افيدكم اكثر واكثر، وراح احاول اني اوسع لكم كل شيء واعطيكم امثله بقدر الامكان. وتابعوني إن شاء الله. شكرا، يعطيكم العافية.